Hey guys, welcome back to another A-level maths video. So still the year 12 content, quite a lot to go through of course. As always, the worksheet is in the link in the description. It's a Patreon link, but it's completely for free. There's also a link to the A-level playlists, and also there is one other announcement I want to make. So the booking for the tuition for sixth form and for GCSE is currently open. So the A-level maths classes are open for booking, so if you do want to book, you can either message me on Discord or you can email me and we will sort out the booking procedure from there. But I just wanted to make you guys aware of it. Also on Patreon there is the Mechanics and Stats course, which is completely live for about £10 a month, so you can have a look at the stuff that's been put on there. But without further ado, let's get straight into the sine rule, the cosine rule, and the area of any triangle. So first things first, let's think about what the different rules are. So first of all, the sine rule, you have sine A over A equals sine B over B, and technically equals sine C over C, but we don't normally use the three-way thing. So this is used when you have pairs, opposing pairs. So the angle, which is the capital letters are all angles, are opposite their lowercase sides. Okay, so for example, if you have a triangle like this, and you have capital A here, then lowercase a has to be there. If capital B is here, then lowercase b has to be here, and so on. And that is one of the equations that you need to use. You can also flip it over with no real change. So you literally just flip the whole thing over, and you can work out the sides. So this is quite useful because it lowers the amount of rearranging you have to do. And there isn't really much to remember, you literally just flip the whole thing. Cosine rule is a bit more interesting, and I use that term very, very loosely. It's a fairly long equation, but effectively all it states is that if you have your three sides here, so A, B and C, then A, the angle, is going to be in between these two. Now, contrary to popular belief, you don't need to remember all of the different equations for this. So some people like to remember a B squared formula and a C squared formula. All you need to do is, if they give you an angle, make that angle capital A, and then label your triangle from there. So that is all I'd recommend. And of course, the area of any triangle is simply a half AB sine C. Basically, it's going to be two sides and the angle between them. That's all you need to care about. So in this case, it would be BC sine A. In this case, it would be, for example, AB sine C, or AC sine B, whatever. You just need two sides and the angle between them. So let's have a look at some actual A-level maths questions. Let's quickly discuss all the different ways that I'm going to help you in your GCSE or A-level maths careers. First of all, I wanted to talk to you about the YouTube members. This is a really cost-effective way of getting tutoring. So I'm going to do weekly live streams for GCSE and A-level maths, and that all comes for £18 a month, and you get at minimum an hour of tutoring per week in these live streams. At the moment, they're quite small, so you basically get tuition for about £4.50 an hour, which is really, really cheap. The second thing is the Patreon. For those of you doing A-level maths, I have already completed AS Stats on my Patreon. It is a full course with worksheets, mark schemes, videos. I answer all the questions. We're going to do exam papers and everything that needs doing. We're halfway through mechanics as of yet. And lastly, there's tuition. I still have places in my group classes for A-level maths and GCSE maths. For GCSE it's £30 an hour, and for A-level it's £40 per hour. So if you want to let me know if you're interested, just email me or join the Discord, where I'm very, very active all the time. Anyways, back to the video. So for the first question, we have a triangle ABC, sine blah, 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 blah. What you need to do is draw a diagram. That is the first thing you want to do. So I'm going to draw a fairly big triangle here, and then all we're going to do is label the sides. So it says triangle ABC, so why don't we just make it ABC? Technically, it doesn't matter what way round we label it, to be honest. AB has a length of 15 centimeters, so I'm just going to write 15 here. AC is a length 12, and then BAC, so that is the angle BAC. This one right here is 60 degrees. Okay, so we're going to put the centimeters here, here. And for part A, it says simply work out the side BC. Now we need to decide what formula we're going to use. Well, if we have pairs, so pair side pairs, as in, for example, if we have the opposite angle here and a side, and then one of either a side or an angle, then we can use the sine rule. But in this case, can you see we have no opposing things? So we have this side here, but we don't have the angle. We have this side here, but we don't have the angle. We have this angle here, we don't have the side. So we have to use the cosine rule. So all we're going to do is say that a, which is this side, a squared, is equal to b squared plus c squared. So these two sides added and squared. So 15 squared plus 12 squared minus 2 bc, 15, 12, cos 60. So remember, A, capital A, is always the angle they give you. And remember, I'm just going to write out the formula one more time. A squared equals b squared plus c squared minus 2bc cos A. So hopefully you remember most of this from your GCSE. So opening up our calculator, let's do 15 squared plus 12 squared minus 2 open bracket 15 times 12 cos 60. And remember, this doesn't give us a, this gives me a squared. So I need to now square root the answer to work out the actual value. So a is simply equal to 13.7 to 3 sig fig. And I'm always write down what you're rounding to as well, just so the examiner knows. That's 3 marks. Pretty easy, I would say. It's kind of a grade 6, 7 GCSE maths question, but hopefully you realise that you've actually gotten a lot better at maths since you did GCSEs. And then find the area of the triangle. Now, with the area of a triangle, I told you that was a half AB sine C, but this doesn't mean you should be looking at finding this angle here. We don't care. Remember, it's just two sides and the angle between them. That's all it is. You don't have to work out angle C in air quotes. It's just two sides and the angle between them. In this case, we can use 15, 12, and 60. So, it doesn't matter which way round you do A and B, because of course we're just timesing them. 15 times 12 is the same as 12 times 15. And sine 60. That will give you the area, nice and easy. So 0.5 for half, just to make my life a little bit easier. 15, 12, sine 60. Gives me 45 root 3 or 77.9 centimetres squared. Don't forget to put your units. Just like that. Not too bad, I hope. Once again, we have another triangle. So we're just going to draw it out. Again, that's the first thing you should do as soon as you see the word triangle. And we're just going to label A, B, C. And it says AB has length 8 centimeters, BC has 7 centimeters, and AC has 6 centimeters. And we need to find the size of the angle. And this is another thing. When you do the sine rule, you have to have at least one angle. Bare minimum. So if you have 3 sides and no angles, you are definitely using the cosine rule again. But you might be asking, how on earth can we use the cosine rule in this case? Well, all we're going to do is do some good old-fashioned rearranging. Now, we want to find the size of the angle ABC, so that's this one. So this is going to be my angle A, which means A squared is going to be 6 centimeters, okay? The other two sides I don't actually care about. They can be B or C. I can make this B and this C, or this C and this B. It doesn't make a difference, okay? 2 ways to do it. You can either rearrange first, then sub it in, or you can just sub it in straight away. I'm going to show you the subbing in straight away version, because I believe when I did it last time, back in ye olde GCSEs, I did it the rearranging method. So I just want to show you the other method. It's basically the same. And all you can do is work all this out. So 6 squared is of course 36. I was about to use a calculator. That was embarrassing. 64.49. And then just because I can't be bothered to work that out, 2 times 8 times 7 gives me 112 cos A. So if I move the 112 cos A to the left-hand side and the 36 to the right-hand side, this is what I'd get. I'd get 112 cos A equals 64 plus 49 minus 36. Let's work out all of that first, just to save me from writing that out. 49 minus 36, 77. So we have 112 cos A. You can do this a bit faster in terms of the rearranging, but again, I'm just making sure that everyone is following A-OK. I would like to point out that there is technically an A to or year 13 version of this. And it's nothing new except we don't use degrees anymore. That's the only new thing. The equations all stay the same, so we don't need to worry too much about it. 77 over 112. 46.6 degrees. The three significant figures again. Not too bad. And then for part B, if I remember rightly, it says calculate the area of the triangle. So we worked out this angle here, so we're going to use these two sides. So half AB, oops, spoilers, half AB, where A and B are 8 and 7 respectively, sine 46.6 degrees. So let's quickly do that. So 0.587 sine 46.6, 20.3 square centimeters. Again, 3SF. Always write what you're rounding to in A level. Now we move on to a new type of question that comes up quite a bit in A level, and people are kind of unsure of how to answer it. So here we get given a right angle triangle because it says sine of this is 2/3 and DEF is acute, and it says find the exact value of cos DEF, and this is where things get a bit more interesting. So what we're going to do is draw out this triangle. We can't assume it's right angle, but we're going to be using a right angle triangle shortly. In fact, let me make this a bit bigger. Look at this 21st century technology. We're going to label it D, E, and F. And we have ED is 5 centimeters and EF is 6 centimeters. And it says the angle DEF, well, sine of that angle is 2/3. So it says find the exact value of cos DEF. So if we have sine of this is 2/3, remember that sine of an angle is equal to opposite over hypotenuse. So we can actually draw out a right angle triangle for this, where if I just move this over slightly, if we call this the angle theta down here, the opposite is 2, so we can put 2 here, and the hypotenuse is 3. So if we're working out cos of that angle, we need, so cos theta, if you remember, is adjacent over hypotenuse. So I need to work out what this side is, which is pretty easy. It's just Pythagoras. And we're working out a missing side that isn't the hypotenuse. So we're going to do square root 3 squared minus 2 squared, which gives me square root 5. Which means the exact value for cos DEF is simply equal to adjacent, which is root 5, over hypotenuse, which is 3. The reason why this works, by the way, is because it tells us it's an acute angle, which means we can actually draw a right angle triangle with it. Remember, in a right angle triangle, there are no obtuse angles, because otherwise the total angles would add up to more than 180. So hopefully that makes sense. It's fairly simple. All you do is you draw a triangle with the information you're given, where if it's sine, it's opposite over hypotenuse. They may give you tan, which is opposite over adjacent, and they may give you cos, which is adjacent over hypotenuse. This, by the way, does come up in the mechanics section of A-level maths as well. So you need to be somewhat competent with it. For part B, it then says, find the length of DF. Now, that's this side here. We actually know what that angle is now, because we already know that it's, root 5 over 3 from here. So, if we look at the formula again for the cosine rule, it asks me for cos of this angle, which is just going to be root 5 over 3. So I can actually sub that straight in. I don't need to do cos of the angle because I already know what cos of the angle is. Cos of the angle is root 5 over 3. So that's the key part here. Then we just need to sub in everything else. So we have a squared equals 5 squared plus 6 squared minus 2, 5, 6 times root 5 over 3. Very handy indeed. I mean, a little bit handy, I suppose. But again, in A-level mechanics, that's actually a lot more important for reasons we may get to. Whoa, hold on. 5 to the power 5, that's way too big. That we may get to a bit later. So -2, 5, 6, and then timesing by, whoopsies, times √5 over 3. Then square root the answer, of course. We get 4.03 to 3 significant figures. And then lastly, we have part C, which simply states find this angle down here. And this is actually very, very, very easy because look, we have an angle and its opposing side, and we have another side and we want the angle. So we're just going to be using the classic sine rule. Sine A over A equals sine B over B. Now, good thing we know what sine of this is. It's 2/3. See? There's always a reason. So 2/3 over A, which is 4.03. So I'm going to do 2/3 like this, leave it in a bracket, over 4.03 is equal to sine B, which we don't know. So we can call that sine, what do they call it? They call it EFD. And they use this little symbol to symbolize it's a angle. I've never been really good at drawing that though, that's why I don't do it. Over 5. So times both sides by 5, we get 5 times 2/3 over 4.03 equals sine. That's a way better version. Good. So then that angle, we're just going to do the rest of it on the calculator now, is equal to something. So first of all, let's enter in this left hand side. So we have 5 multiplied by, open bracket, open the fraction, then bracket, then open another fraction, 2 over 3 over 4.03. And then we're going to do inverse sine, because we want to get rid of the sine on that side. Answer button, 55.8 degrees. Once again, to 3SF. By the way, if you round that value, you may get a slightly different answer, like 55.7 or 55.9. You still get the marks, okay? Because what they do is they use your values to work out the answer. So it will work. Don't worry too much about it. And this is the kind of last style of question that you can give you, where they try and give you a little bit of problem solving. But hopefully you guys watched the last video on solving trigonometric equations, because that's actually going to play a little bit of a role in this case. So let's just have a look at the question and see what happens. So it says in the triangle ABC, and then it gives us information. So once again, starting off with the classic, draw a little diagram to help us out. A, B, C. AB is 13 centimeters, BC is 10 centimeters, and BAC, this angle here, is 30 degrees. And it says find the two possible sizes of angle ABC. So basically, work out this angle here, and then give your answer to blah, 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 blah. So all we really need to do there is work out what this angle is using the sine or cosine rule. But then why is it saying possible sizes? Well, that's where things get a bit more interesting, and we will come on to that in a second. So first things first, you might notice we can't actually work out this angle straight away. We have to work out this angle down here, and then just do 180 minus 30 minus this angle, because we don't have enough information to work out B. So I'm going to name this angle theta. So if we now do the sine rule for this, we have sine 30 over 10 equals sine theta over 13, almost messed that up, times 13 by both sides. So we have 13 sine 30 over 10 equals sine theta. And this is where we're going to get multiple values. So I'm going to work out what theta is. And this is actually going to give me multiple values. Now my calculator isn't going to give me multiple values, but there's actually going to be multiple values. So do all this. 40.5 degrees, or 40.54. Let's leave it at 2 decimal places at 40.54 degrees. Now, I mentioned to you in the last video, and I thoroughly recommend you at least watch the introduction to that video, that whenever you take the inverse sine of a value, there's actually an infinite number of answers. Infinite. Because if you remember, the sine graph repeats itself. So I'm just going to quickly do that demonstration. Right? And it goes on absolutely forever. So at any given point, it has an infinite number of answers for any y value. Okay? Well, the ones that are actually in the sine graph anyway. So we have to use the cast diagram now. And now this is where we need to actually use our noggin, because normally they give us a range, right? So they'll say from 0 to 360 or something like that. Let's use our brains for a second. What's the range going to be in this case? Well, we could take 0 to 360 if we want, but I know it's going to be between 0 and 180, because if the angle is above 180 degrees, it can't make up a triangle, because all of the angles need to add to 180. Likewise, it can't be negative, right? You can't actually have a negative angle for a triangle. So, I know it's between 0 and 180. And because it's sine and it's a positive value, we're going to put lines in the two positive values here. So that is our first value of 40.54. Which means that's also 40.54. Again, we go through all of these examples in the last video, so I thoroughly recommend you watch that. So we're looking for this this obtuse angle, which is going to be 180 minus 40.54, which, if we just do it on our calculator, we have 180 minus 40.54. And remember, they did actually say there'd be two different values, didn't they? And we have two different values. Now, this isn't my answer. I know, right? It seems a bit strange. But remember, we're not looking for this angle at theta. We're looking for the angles ABC. So all we need to do for angles ABC is we're going to do 180 minus 30 minus this value, then 180 minus 30 minus this value. That's going to give us the possible values there, okay? So let's get to it. So 180 minus 30, whoopsies, not 3 point, minus 40.54 gives us our first value for B, which is 109.46. And the second value is going to be the same thing, except instead of 40.54, it's going to be 139.46. That's a 6-mark question. Not too bad. 10.54 degrees. All to 2 decimal places. And lastly, of course, they can shove a bunch of algebra in our face because they hate us. But again, it's not that bad. So again, what's the first step? Draw a diagram, just like with everything in A-level maths. Well, everything that you can do anyway. Let's draw our triangle and label this person up. So we have x plus 3, x plus 2, and x. And the angle BAC, which is this one here, is 60 degrees. Find the value of x. So what you want to do here is essentially just use the cosine rule. Nice and easy. So cosine rule will be a squared equals b squared plus c squared minus 2bc cos a. So a is going to be the opposite side, so a is here. B and c are just going to be the two other sides, doesn't matter which way around they are. So we have x plus 2 squared equals x plus 3 squared. Yeah, this is going to be a fun question, isn't it? Plus x squared minus 2 x plus 3 x cos 60. Yeah, this is going to be fun. And of course you can use the calculator to work out the value of cos 60 if you don't know it. Depends on if you remember it or not. It does equal a half, which actually makes our life easier because we can cancel the 2 and a half, right? Because 2 times a half will give me 1. So that makes my life slightly easier, thank God. And then expanding the brackets, we get x squared plus 2x plus 2x, that's plus 4x plus 4 equals x squared plus 3x plus 3x, so plus 6x plus 9 plus x squared. Then we're going to have x times x, which is x squared, but it's a minus, so minus x squared. Then we're going to have minus 3x. So we can immediately cancel out those two x squareds. Perfect, so now we can simplify this. So we have x squared plus 4x plus 4 equals just x squared plus 6x minus 3x, that's plus 3x, and then plus 9. We can then minus x squared from both sides. That makes my life slightly easier again. I'm going to move the 3x to the left side and the 4 to the right side. That gives me x equals 5. 5-mark question. Not too bad, eh? 5-mark question. So I hope you enjoyed this video. Again, just as a reminder, the link to this worksheet is in the description. It's a Patreon link, but it's completely free for everyone to look at. I'd recommend doing or attempting these questions again in a day or two just to make sure you've retained some stuff, and it will help you kind of make the knowledge concrete in your mind. There's also, check out the Patreon because it does have the mechanics and stats stuff on there, which I'm constantly updating. And lastly, we have the A-Level Maths playlist, which has all of my videos from last year, the live lessons, just like I did the GCSE live lessons. And again, we do have those tuition lessons open for September. So email, Discord, message me. But other than that, hope you have a wonderful day and are enjoying your summer.